Hello, we will solve the parametrized system in this video. Suppose you have a parametrized system. We want to solve it for parameter m, for m belongs to R. And here we have the system and we will solve it for the parameter m. Okay. Since this is the system of linear equations, so first of all, we will make an augmented matrix, then we will solve it by Gauss-Jordan method. So first of all, I will write an augmented matrix, which is this one. And now I will apply the Gauss-Jordan elimination method. So first of all, I will find the leftmost non-zero column, which is this one, and then I will check its top entry. I'll make it 1 since it is already 1. So this is my pivot entry. So once I find the pivot entry, then I have to make everything below 0 as well as above. Since there is nothing above, so I will make everything below 0. How can I make this 0? Because this is the pivot, I will use the pivot entry and I will make this 0. So this is 2 minus something times pivot. Pivot is 1 and this something is of course 2. And this 2 is coming from R2 minus this is the scalar. I will write the scalar, and this 1 is coming from pivot and pivot is in R1. So this is the operation which I'll apply in R2. So I will apply this operation in R2 because I have to make changes in R2 because here I want 0. Okay. So apply these changes in R2. When I'm applying changes in R2, that means the first row will be fixed, will remains fixed. Okay. So I have written R1 as it is, and here I have to write R2 minus 2 R1. So first of all, I will write R2. R2 is 2 minus m, m0. I will write 2 minus m, then m, then 0. Okay, 2 minus m, m0. And then I have to write minus 2 times R1. So minus 2 times R1 is 1 here. Again, minus 2 times R1 is 0. Minus 2 times R1 is 2m. Minus 2 times R1 is minus m. Perfect. Now I have made this entry 0. Now I want to make this 0. Okay. So here I will apply another operation to make this 0. How can I make this 0? This is 1. I have to write something and I have to use the pivot. Pivot is 1, so pivot will be here. So what should be here? Of course 1. Okay, 1 minus 1 times 1 is 1, which is 0. Okay, so this 1 is coming from R3 minus this 1 is coming from the scalar. So I will not write the scalar because this is 1. 1 times 1 is 1. So I will not write this one. But this one is coming from the pivot, and pivot is in R1 here. So I will write R3 minus R1. So this is my operation which I'll perform, R3 minus R1. So I will perform this operation here, R3 minus R1, and this thing will be happened in R3. So I will make these changes in R3. So first of all, I will write R3, and R3 is 1 minus 2 m1. So 1 minus 2 m and 1 minus R1. So minus everywhere. Now what is R1? R1 is 1 0 2 m minus m. 1 0 2 m minus m. Okay. Now I will use calculator to calculate these two rows. Okay, so after calculation I got this matrix. Now this is my current pivot. If I skip this row and this column, I will get this submatrix. So in this submatrix, so I will consider this submatrix. In this submatrix, I will again do the same operation. So that means I have to find the leftmost non-zero column. So here the leftmost non-zero column is this one. So in this column, I have to check the top entry. The top entry, I have to check whether it is non-zero or zero. I don't know. Since the topmost entry is minus m, and I'm not sure whether m is 0 or non-zero because it is unknown. So when something is unknown, then you are not sure about it, because I want to be sure about this m. If it is non-zero, then I will proceed. If it is 0, then I can't. Since I'm not sure, so I will swap these two rows. Then I will move minus 2 up because I'm sure about this element. This is non-zero because this is minus 2. So I will swap this row with this row. Okay, so what to do? I will swap R3 with R2. So I have swapped R3 and R2 with each other. Now this is the submatrix, and in this submatrix, this is the leftmost non-zero column and its top entry is non-zero. I am sure about it. Now I have to make this entry 1. How can I make it 1? It's very easy. If I divide this row by 2 minus 2, then it will be 1. So when I divide R2 by minus 2, I get this value. Okay. Now this is my current pivot entry. I have to make 0 here and here, top and bottom. Since on the top there is already 0, so I will make this 0. How can I make this 0? Look, this is minus m plus I should write something times the pivot. Since the pivot is 1, so I will write here 1. Since anything multiplied by 1 is that thing. So minus m plus what is equal to 0? What you would add to minus m to get 0? Of course, this is minus m. If you add plus m, it will be 0. Okay, so I should write here m. So this minus m is coming from R3 plus this m is the scalar, I will write as it is, and this 1 is the pivot entry which is coming from R2. You can check. Okay, so this is the operation which I'll perform. So I perform this operation in R3, so that means my R1 and R2 will remain fixed. Okay, so I should write R3 plus m R2. So R3 is this one, 0 minus m minus 3m, 2m. 0 minus m minus 3m minus 2m. Sorry, plus 2m. Here I should write 2m. So I have written R3. Then I will write plus m. So plus m everywhere, plus m plus m plus m times R2 times R2. What is R2? R2 is 0 here. R2 is 1 here. R2 is m by 2 here. R2 is minus 1 plus m by 2 here. So these calculations are complicated. Look at that. This is 0 plus m times 0, which is 0. 0 plus 0 times something, 0. Minus m plus m, this is also 0. So I have written here 0. This one is minus 3m plus m square by 2. Minus 3m But this m will multiply with this one. I will write m square by 2. So minus 3m plus m square by 2. And if I solve this one, let's check what will happen. 2m, this minus and this plus will become minus. So I will write minus m times this entry. M times, I will write m times 1 plus m by 2. So if I take LCM, or if I make their denominator common, because its denominator is 2 and its denominator is 1, if I make their common denominator, its denominator must be 2 because its denominator is 2. How can I make this 2 if I multiply and divide by 2? Okay. So what will happen if I multiply and divide it by 2? It is 4m by 1 multiply 2 is 2 minus m times 1 plus m by 2. Now you can check their denominator is same. What will happen now? I can write their common denominator as 2, then 4m minus m times 1 plus m. Okay? So if I solve it more, I can write it in this way. 4m minus m times 1. Now distribute this m inside. M times 1 plus minus m times m. Minus m times m is m square. Okay, so what is 4m minus m? 4m minus 1m is 3m. 3m minus m square by 2. Now if I take m common from both, what will I get? 3 minus m. Because this is 2 times m. I mean this is m times m. So once I take 1m here, I will left with 1m here, okay? And this is the final thing which I will write here, okay? So I will write m times 3 minus m by 2. And similarly, if you want to solve this one also, you can do that, because this is minus 3m plus m square by 2 minus 3m. First of all, you have to make their denominator common, because its denominator is 2 and its denominator is 1. So I will multiply and divide by 2 to make the common denominator. Now you can check its denominator is 2 and its denominator is 2. Okay. So what will I do? I will multiply this 2 with minus 3m. So 2 times minus 3 is minus 6m by 2 plus this value m square by 2. Now 2 is common. I can write 2 common. Minus 6m plus m square. Since m square means m multiply m. Right? It is m times m. Now I can take m common, right? So, okay, let me write m times m, because m square is m times m. Now I can take 1m common from both. So if I take 1n common, this one and this one is taken out. So what I left here? Only minus 6. What I left here? Only the other m, because this m is taken out and this m is left. Okay, so I will write plus m by 2. So I will write this value here instead of this. So I will remove this value. I will write this value. M times minus 6 plus m. M times minus 6 plus m by 2. Now, what should I do? This is the pivot entry, everything below is 0. This is the pivot entry, everything below and above is 0. Now, if I make submatrix this one, in this submatrix, this is the leftmost non-zero column and it must be non-zero. Okay, we are interested in this entry to be non-zero. Okay, so but we are not sure about it. It can be 0 and it cannot be 0. We will consider both cases, what will happen. Okay. Okay, so let's check. Let's make the cases for this entry. So I will make the first case. In the first case, I will assume that it is non-zero. If it is non-zero, then this will be my pivot entry and I will get a solution. So I will consider case 1 if this is not equal to 0. Okay, what does that mean? This means m times minus 6 plus m is not 0. Because this is not 0, I know. So I am not sure about it. So that's why I will just write this value. So, and you know, these things can only be 0 if this is 0 or this is 0. So I will write neither m is 0 nor minus 6 plus m is 0. Okay, I will say that neither this m0 nor this m is 0. Okay, so both should be non-zero. Okay, because in the first case I need here 1, so I can only make it 1 if this thing is not 0. Okay, so this is only possible when m is not 0 and m is not equal to, if you take this 6 here, it will become plus. So I will write m is not equal to plus 6. So these two values are very critical values, because if m is 0 or m is 6, then this whole entry will become 0. If it will become 0, then I cannot get here 1. If I cannot get here 1, then I cannot get the unique solution. You understand that? Okay, so if both values are not 0, then I can get here 1. How can I get here 1? I can divide this, the last row, by this entry. Okay? What will happen if I divide the last row by this value? Because you know, something divided by the same thing is 1. So if I divide the last row by this value, then this value will become 1, because I will be writing this m times minus 6 plus m by 2 divided by m times minus 6 plus m divided by 2, because I am dividing this whole row, each entry of this, with this value. Okay, okay, so this will become 1. What will happen to this thing? So this became 1. What should I write here? Let's have some calculations. Since I have to divide this entry also by this one, I should write m times 3 minus m divided by 2 divided by this entry, because I am dividing this whole row by this. Okay, so I should write m times minus 6 plus m by 2. You can check this m and this m will be cancelled. This 2 and this 2 will be cancelled. I will get 3 minus m over minus 6 plus m. So I will write this value, 3 minus m over minus 6 plus m. So I will write this value, right? 3 minus m over minus 6 plus m. 3 minus m over minus 6 plus m. Now this is my pivot entry. Now I have to make this 0 and make this 0. So let's check how can I make this 0. You can check this value is m by 2 minus I should write some value times the critical times the pivot entry. And since 1 times anything is the same thing, what should I write here? Since this is m by 2, so I should write minus m by 2 here. Since this is minus, so I will write m by 2. So this m by 2 is coming from R2. This m by 2 is the scalar. I will write m by 2. And this one is coming from the pivot, and the pivot is in R3. I will write R3. So this is the operation which I'll perform. So what will I do? I will write this operation, and since these changes will be made in R2, so I will make these changes in R2. First of all, I will write R2 everywhere, R2, 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 R2. Okay, then I will write minus m by 2 times R3. Minus m by 2 times R3 is 0. So I will not write here. Similarly here, minus m by 2 times R3 is 0. So I will not write here. Here I will write minus m by 2 times R3. R3 is 1. Okay. Also here, minus m by 2 times R3. So I will write here 3 minus m over minus 6 plus m. Okay. Now I will make here 0 too, because I have made here 0. Now I will make here 0. How can I make this 0? It's very simple. 2m minus something times pivot. Pivot in this column is this one. I will write his 1. You know, what should I put here? It's obvious that I should put the same thing here. 2m. So this 2m is coming from R1 minus this 2m is coming from the scalar. I will write 2m. And this one is coming from the pivot, and the pivot is in R3. So I will write R3. So this is the operation I will perform in R1. Okay, let's perform this operation in R1. So what to do? R1 minus 2m. So let me write R1 first. This is R1, this is R1, this is R1, this is R1. In R1, I should write R1 first. Okay. Minus 2m everywhere. So I have to write minus 2m times R3. R3 is 0, so I will not write here. Similarly, minus 2m times R3. R3 is 0, so I will not write this here. Okay. Here I will write minus 2m times R3 is 1. So I will write this. Okay. Similarly, again minus 2m minus 2m times R3. R3 is this value. I will write here 3 minus m by minus 6 plus m. Now you can check this is 0 and this is 0. Okay. So I have put here 0. Now what to do here and what to do here? These are some calculations which I can make. At this position, I have to do these calculations. Okay. So let's do these calculations here for you. And then after solving, I will write here. Okay. So this is minus 6 plus m. Okay, I can write minus m minus. I will multiply this thing with this one. Okay, I will write plus minus 2m times 3 minus m divided by minus 6 plus m. What I have done, I have multiplied this thing with the numerator, okay, with minus. So I have multiplied with minus, therefore I have written here plus. Okay. Now you can check there are only two values, this one and this one, but the denominator of the second value is minus 6 plus m. The denominator of the first value is 1. So I can make their common denominator. How can I make it? I can make it by multiplying and dividing with the same thing. How? How can I do that? I have to multiply and divide with this thing, minus 6 plus m minus 6 plus m with this one. Okay, I have to multiply and divide by minus m. Now you can check minus 6 plus m times this minus m divided by minus 6 plus m plus this same thing. Okay, this is okay, multiply minus 2m times 3 minus m over minus 6 plus m. Now their denominator is common, so I can write their common denominator, which is minus 6 plus m. Now you can multiply this minus m with this and with this. Okay, minus m times minus 6 is 6 times m, because minus minus is plus, and minus m times plus m is minus m times plus m. Okay, I can write m square, but I will not. Okay, then I will multiply this thing inside. Minus 2 times 3 is minus 6, so I will write minus 6 m, and then I will multiply this thing here. Minus minus is plus, because this is minus and this is minus, so minus minus will become plus. So I will write plus 2 times m times m. Okay, now I can do more calculations. You can check this 6m minus 6m will be cancelled. This is 2 times and this is minus 1 times. So if I subtract 1 time from 2 time, I will get 1 time. So I will write 1 times m over minus 6 plus m. What does that mean? M square by minus 6 plus m. So this is the thing. So I will write m square over minus 6 plus m. So I will perform similar calculations for this, for this value. How can I do that? Let's look. So this is the thing which I have to solve. So first of all, let's write as it is, 1 plus m by 2 minus, multiply this m inside and this 2 inside. Okay, I will get, okay, just write here plus and multiply it with by minus 1, minus m. 3 minus m over 2 times minus 6 plus m. Okay, now I have to make the denominator common. How can I make it? You can check that the denominator of the second term is this one and the denominator of the first term is 2. So 2 is common, but this thing is not common. So I have to multiply and divide by this thing. Okay, so I will multiply and divide by minus 6 plus m minus 6 plus m. Now let's do more calculations. So the first term, I will multiply this with this term. Okay, I'll multiply the first term with this term. So minus 6 plus m times minus 1 minus m, because this minus will be multiplied with 1 as well as with m. So that's why I have written minus 1 minus m. Okay, and below, what's the denominator? In the denominator, I will multiply this with 2. I will write 2 times minus 6 plus m, plus, do this thing as it is, minus m times 3 minus m over 2 times minus 6 plus m. Now you can check that the denominator is common. So what will I do? I will write 1 times denominator rather than twice, minus 6 plus m 1 times. I will write these terms. I'll multiply them. First I will multiply minus 6 by minus 1. Minus 6 by minus 1 is plus 6 because minus minus plus. Then I'll multiply minus 6 by minus 1, minus m. That means again minus minus plus, so I will write plus 6 times m. Now I multiply m with minus 1, so I will get minus m. Now I multiply m with minus m, I will get minus times m square, okay? Plus, I will do these calculations, okay? Minus m 3 times minus 3m, so I will write minus 3m. Minus m minus m times plus m square, I will write this thing. You can check plus m square and minus m square are cancelled. And then I will write this 6 plus 6m minus m is 5m, and this is 5m, this is minus 3m. So 5 minus 3 is 2m. I will write 2m over 2 times minus 6 plus m. You can check that I can take common 2 from the above. So if I take common 2, what will I get here? I will get 3. Plus, what will I get here? 2 is common, so I will get m. 2 times minus 6 plus m. You know how I take common 2? Because if I multiply 2 inside, I will get 2 times 3, which is 6. I will get back 6. If I multiply 2 with m, I will get 2m. I will get back 2m. So that means this step is true. I can cancel these two things. So I will end up with this value, 3 plus m over minus 6 plus m. I will write 3 plus m over minus 6 plus m. So after little calculations, I get this value. Okay? Now come back. Now you can check that value of x is this one, the value of y is this one, the value of z is this one. So I got the unique solution. Here you can check x is equal to m square over m minus 6, because I can write this m minus 6. And y is equal to, from here, y is equal to 3 plus m over m minus 6. And z is equal to 3 minus m over m minus 6. This is the unique solution when we assume that m and m is neither equal to 0 nor equal to 6. What will happen if this is not the case? So if this is not the case, then either m will be 0 or it will be 6. What will happen then? So in the second case, if m times m minus 6 is 0, okay, this is the second case. Because previously we assumed that it is not 0, okay, minus 6 plus m. I should write minus 6 plus m, sorry, minus 6 plus m by 2. If this is 0, what will happen then? This means m times minus 6 plus m is 0. And now we get two cases. Again, inside case 1, okay, there are two cases for case 2. I will write case 2a. Okay, this is the first part of case 2, because when this times this is 0, this means either this is 0 or this is 0. In the first case, I will assume that m is 0. And in the second case, I will assume that this is 0. Okay, so first I'm assuming that m is 0. When m is 0, what will happen then? Then I will put m0 here in the whole matrix everywhere, right? So I will place m is equal to 0. Here I will write 0. Here I will write 0. Here 0 times, because m is 0. If I multiply 0 with inside, everything will be 0. So I will write here 0. Here this will also be 0, because m times 0 times 3 minus 0 is 0. So this is also 0. And it will be minus 1 plus 0 by 2, which means minus 1/2. So I will write minus 1/2 here. And this m is 0, so I will write here 0. Okay. So what will I get? I will get x is equal to 0. This means x is equal to 0. And what is y? Y is equal to minus 1/2. And since there is no pivot entry in z, so z is free. Z is free, that means I can write z is equal to t, where t belongs to real numbers. So that means there are a lot of solutions. So I will write solution set in this case. X is 0, y is minus 1/2, and z is t, where t belongs to R. So this is case 2a. What is case 2b? Case 2b is, because this is the equation, m times this is 0. So there are two possibilities, either m is 0 or this is 0. So this is 0 means I'm going to case 2b. So case 2b means minus 6 plus m is 0. Now case 2b, minus m plus 6 is 0. This means m is equal to 6, because I can take this m here, so I will get m is equal to 6. Now I have to put m is equal to 6 everywhere in the matrix. This is the matrix where I have to put m is equal to 6. Okay, let's put m is equal to 6 everywhere. Here also, minus 6 plus 6. Here also, minus 3, 3 minus 6, 6, and minus 6. So what will happen if I solve these values? I will get this. Then this is minus 6 plus 6, which is 0. So I will write 0 here. And this is 6 times minus 3, because this is minus 3. This is minus 18. Minus 18 by 2 is minus 9. So what will happen? R3 implies this is 0 is equal to minus 9. This is a contradiction. It cannot happen. This is the contradiction. This contradiction says that m is equal to minus 6. So for m is equal to 6, we have no solution. So for case 2b, or m is equal to minus 6, we have no solution. So We only have solution for non-zero, non-critical values of m, and m is equal to 0. For m is equal to 6, we have no solution. So now we have considered all the cases and we have found all possible solutions for this parametrized equation. So I think we have discussed the Gauss-Jordan method enough. And in the next video, we will do some couple of examples and then we will end this section.